Good afternoon, ladies and gentlemen. I don't see ladies around, uh, but that's all right. Uh, I understand that the post-lunch sessions are somewhat easy to moderate, and the menu of the lunch has been excellent. So my task hopefully has become a little easier. And my colleagues here have made it further easy because I come from the hardcore insiders of the Merchant Navy, and Rear Admiral Nadkarni has allotted hardcore insiders of Indian Navy. So, so that has made matters hopefully simpler for me. Actually, I am on a learning mission by being the moderator, and at the outset, I would like to congratulate because I have been given only 5 minutes to sort of make preliminary remarks. And having made my preliminary remarks about my colleagues, I would like to congratulate Admiral Nadkarni, my friend Captain Anand Dixit, for the excellent arrangements for this seminar. The pains that they have taken in bringing out the booklets and the meticulous care that they have exerted in all directions, I like to congratulate them. It's the model of a seminar, really. I happen to be associated with CMMI, and I'm also associated with Institute of Marine Engineers to some extent. And of course, I'm with IMF ever since IMF was founded by my late friend Rajan Veer. So I'm very happily placed, Admiral Nadkarni, today. Having said that, we don't want to misfire on timings. I have been allotted 1 hour. I have 3 officers from Indian Navy. I have no doubt that they will observe the time frame, and we can start with the very first speaker. I will go by the subjects. Warship design, I think, Rear Admiral Bakshi. May I request you to take the floor?
Good afternoon, everyone. Before I begin my today's talk, I must say that I am filled with sense of gratitude, pride, and eagerness. Gratitude for all the veterans, planners, and naval visionaries who took bold decisions to be self-reliant in naval design and shipbuilding, and imposing the trust on Warship Design Bureau. Also, scientists, engineers, and industry partners who joined us along the way. Pride is for what we have been able to achieve, and the sweet spot in development and confidence that we are currently in. And eagerness is to achieve more, to create a path for the younger generation that is fearless, confident, motivated, and bubbling with energy. Hence, the topic, Century and Beyond, celebrating 100 warships designed and constructed by Warship Design Bureau. By naval visionaries with setting up of Corps of Naval Constructors in 1956. And it continues today with design of next generation of warships. Our journey started very early with design of INS Ajay and INS Darshak. Although some vessels were being procured from then Soviet Union and UK, naval self-reliance was triggered with the 4th Defense Plan of 1969-74. With more than 20 indigenous warship designs and 102 vessels delivered, from small craft to weapon-intensive platforms and aircraft carrier, the Bureau stands as the beating heart of India's naval innovation and sovereignty. Even as India's commercial shipbuilding industry was battling headwinds, our naval shipbuilding efforts have kept our will alive, our skills honed, and our confidence unwavering. Each warship embodies India's relentless innovation, unwavering sovereignty, and growing national pride as the story of self-reliance sails forward. WDB's early triumphs included licensed Leander-class frigate production and modest homegrown designs like ocean-going tugs and Sandhaya-class survey vessels. Emerging stronger post-1971, the Godavari-class frigates redefined India's naval capability with a revolutionary hull and advanced weapon systems, heralding a new era of indigenous warship design. Magar-class LSTLs marked India's entry into complex warship design with advanced weapons, sensors, and helicopter capability, serving as effective troop and vehicle carriers. Alongside, Khukri and Kora-class corvettes have been dependable, weapon-packed vessels essential to Indian Navy's operational strength. The Project 15 Delhi-class destroyers, India's first gas turbine warships built between 1997 and 2001, advanced multi-domain warfare with sophisticated weapons and sensor suites. Following them, the Brahmaputra class introduced indigenous combat data systems, and the Shivalik class frigates pioneered stealth, automation, and integrated fleet command capabilities, marking key technological milestones. The Project 15 Alpha stealth guided missile destroyers and advanced stealthy transformation of the Delhi class stand as powerful destroyers, while the P-28 ASW stealth corvettes feature cutting-edge indigenous systems. The Vishakhapatnam class destroyers P-15 Bravo, an advanced evolution of the Kolkata class, boast enhanced stealth automation and ordnance, with INS Surat achieving a 60% reduction in build time. The P-17 Alpha stealth frigates further elevate stealth capabilities over the P-17. Presently, we are working on NGC frigates, landing platform docks, next generation destroyers, taking our competence to next level. INS Vikrant's commissioning in 2022 elevated India into an elite league of nations, mastering the design, construction, and operation of aircraft carriers, embodying the Indian Naval Warship Design Bureau's crowning technological triumph. I think 2022 has been the 1983 moment for India's shipbuilding. We can already see all that is changing around us. Advanced computational fluid dynamics and experimental analysis, paired with state-of-the-art radar, weapons, propulsion, and electronic warfare systems, setting a new global benchmark in naval innovation and strategic dominance. I must highlight that the journey so far was not alone. In order to realize these designs into potent platforms, the Bureau interacts with various agencies involved in the shipbuilding ecosystem of the country. Recently, WDB has also found representation in Ship Design Research Committee for National Shipbuilding Mission, being steered by Ministry of Port, Shipping and Waterways as part of ship design. The actual design work is iterative in nature, which is depicted typically as design spiral. The tedious process is undertaken by carefully considering various design features and keeping the mission requirements at the core. The techniques such as advanced computational fluid dynamics, aerodynamic studies, experimental analysis, seakeeping and maneuvering studies, structural design, state-of-the-art radar and weapon integration, propulsion configuration, stealth and survivability studies are meticulously carried out as part of ship design analysis. Our core ethos of self-reliance drives the relentless pursuit of surpassing existing capabilities by maximizing indigenous content and deepening technological expertise. This is where I would like to point to the banner. If you look at the banner, whatever we may do at the top, there are industry partners and shipyards who are at the bottom, who are the foundation of whatever we do in this effort. The Bureau is pioneering the integration of manned-unmanned naval operations, integrating autonomous platforms such as unmanned surface, underwater, and aerial vehicles for multifaceted roles, including surveillance, anti-submarine warfare, and technical reconnaissance. We are innovating propulsion technologies with advanced indigenous solutions, including integrated full electric propulsion, systems for enhanced flexibility, fuel efficiency, and low acoustic signatures. We are also working on optimized diesel engines and high-performance gas turbines. Development of advanced nuclear propulsion technologies will ensure our large ships to achieve high endurance and strategic autonomy for sustained global naval presence. The Bureau is exploring novel hull forms to enhance performance, including small water plane area twin hull swath designs for improved stability in rough seas, hydrofoil configurations for high-speed operations with reduced hydrodynamic drag. These innovations promise substantial gains in speed, stability, and fuel efficiency, enabling Indian warships to perform across diverse operational scenarios, from literal missions to blue water deployments. The Bureau is driving total design sovereignty, extending its expertise beyond hull design to include propulsion systems, advanced sensors, and integrated combat systems. Embracing the mantra of Make in India, evolving to Design in India, the Bureau is future-proofing naval platforms through cutting-edge technological innovations. Indigenous warship building transcends defense, serving as a key driver for national economic growth, with a powerful multiplier effect across diverse domestic industries. For every rupee invested, an estimated rupees 1.82 recirculates into the Indian economy, fueling sectors like steel, electronics, and heavy engineering, thereby reinforcing the Atmanirbhar Bharat mission by linking strategic security needs directly to economic expansion. The naval shipbuilding industry's labor-intensive nature, with an employment multiplier of 6.4, means each direct job supports multiple indirect jobs in related sectors. Major projects generate over 20,000 jobs and drive skill enhancement in naval architecture, metallurgy, and advanced manufacturing, while strengthening local supply chains and uplifting India's MSME network and industrial technology. In light of government's impetus to boost shipbuilding and Maritime Amritkal Vision 2047, Warship Design Bureau is strategically extending its expertise beyond defense to bolster India's blue economy. We are offering support for institutions like Ministry of Ports, Shipping, Waterways, DG Shipping, IWI, Classification Society, private design houses, etc. By extending technical assistance to these emerging commercial sectors, we aim to enhance national maritime prosperity and unlock new avenues of growth by sharing experience and knowledge gained over last 70 years. WDB is a strategic engine of India's naval shipbuilding, delivering combat-ready platforms while building national industrial and human capital, thus transitioning India from naval buyer to a global builder and solidifying its blue water navy status for the future. While naval ship design and innovation is its core functions, WDB also plays vital role in uplifting overall maritime environment. So what keeps us going? These are not just slogans, but our source of motivation to continue our efforts towards nation building. The Honorable Raksha Mantri during the twin commissioning of INS Udaygiri and Himgiri has given a clear objective to design and build 100 ships in next 25 years. And this is our guiding light, our crest. It depicts the state-of-the-art warship that we continuously endeavor to deliver to the Navy by unleashing the power of design. And this we have been doing since 1964. Thank you. Jai Hind, Sharnoban.
Thank you so much, Rear Admiral Sujit Bakshi. Well, within time, you have presented your talk, and it has covered quite a wide-ranging activities of your bureau. Thank you so much. May I invite now Commodore Sumit Shidore on the field of refits, which I assume is an extension of warship design. I don't know whether I'm right there or not.
So you're absolutely right, sir. What they don't design, we repair. Captain Anand Dikshit, President IMF, Vice Admiral Vinod Pasricha, flag officers, Captain Sudhir Nafade, the moderator for this session, distinguished guests from the maritime fraternity, ladies and gentlemen, a very good afternoon to you all. As General Manager refits of the Naval Dockyard Mumbai, the theme for today's seminar is both a professional doctrine and personal conviction. In the next 20 minutes, I will give a brief insight on the contemporary and futuristic technologies and organizational framework for safe and reliable repairs at Naval Dockyard Mumbai. The sea has long been humanity's most unforgiving teacher. It rewards vigilance, but punishes neglect without hesitation. In an era when our vessels think, sense, and sail with unprecedented autonomy, safety can no longer be considered as a checklist. It must be a culture, and I think a lot of people in the earlier sessions have talked about it, and that should be embedded in our conscience. Safety in the Navy is therefore embedded as a culture and is practiced with utmost diligence in all facets and responsibilities. While the present session is specifically for ship stability and hull design, I would like to take this opportunity to give a brief, since none of the naval officers have spoken so far, I would like to give a brief insight into the Indian Navy's robust safety structure and also cover the safety framework at the Naval Dockyard. Accordingly, the scope of my presentation is as flashed on the screen. Behind every stable and mission-ready ship lies a meticulous organizational framework, one that integrates design, refit, quality assurance, and operational feedback into a seamless cycle. At the apex level, the Vice Chief of Naval Staff heads the Safety Committee and is supported by the Directorate of Naval Operations for formulating various policy decisions. Traditionally, the safety class authorities, that is a flag officer sea training and flag officer submarines, have been auditing safety compliance on board ships and submarines. In order to accord enhanced impetus and focus approach to safety aspects, Indian Navy Safety Team was established in Kochi in 2017, which functions in consultation with the safety class authorities. Safety in the field and ashore units is monitored by the commands, area headquarters, and fleet formations. The Indian Navy safety team is staffed by respective domain experts and has an explicit mandate to bolster the safety culture in the Indian Navy such that each individual in his sphere of influence is capable of identifying risks, implementing mitigating strategies, and managing hazards without compromising mission accomplishment. INST accordingly analyzes operational and safety aspects and infringements pan-Navy with the principal objective to reduce their recurrence. In doing so, it leverages advanced tools such as the in-house safety trending analysis tool. Further, the Indian Navy has also a pool of officers qualified in human factor analysis and classification system and accident mapping who are appointed across the Navy at various units towards I think more than the audience, I think the computer has gone off to sleep, sir.
Well, they will do the accident mapping.
So these officers are appointed across the Navy at various units towards identifying active and latent unsafe operations. The overarching objective undeniably remains to implement safety to the T. With this brief insight into the Indian Navy's safety structure, I would like to give an overview into the safety culture being followed in operational and refit processes. Indian Navy ships deploy extensively and for extended durations across the IOR and even beyond, often under hazardous and demanding conditions, and therefore prolonged sustenance underpinned by safe practices and standard operating procedures in every sphere of operations and maintenance is a pivotal factor. The Indian Navy today practices operational risk management and time risk management as intrinsic processes in day-to-day functioning on board ships and submarines. The slide depicts the 5 steps being followed in each process, and these are further undertaken at sea as a precursor to every evolution. These practices have reaped immense benefits and provide a methodical way of identifying and managing risks. With an objective to ensure that every Indian naval ship achieves full combat readiness after a layoff on account of refits and is compliant with all safety guidelines, a concept of transition cycle from refit to operations is followed in the Navy. This transition cycle is divided into 4 phases, and each phase is marked by safety audits and performance trials by various agencies. It is also juxtaposed with intensive crew training. Phase 1 is a pre-refit phase wherein extensive trials and safety audits are undertaken to assess material shortfalls with respect to operational and functional safety. These form the basis for a refit package. Phase 2 is the refit phase, which witnesses quarterly safe audits by external agencies to ensure that adequate safety measures are in place, including enhanced emphasis on hot work organization. A concept of refit pause has also been recently introduced, where a complete day is given off in a quarter for a ship to entirely focus towards assessing the materials and crew readiness and to tackle any emergency. While a refit ship is highly vulnerable to fire incidents, all refit ships are equipped with additional fire detection systems installed in plug and play mode. Phase 3 is the most critical phase and commences in the terminal stage of the refit. It extends beyond refit completion and encompasses pre-refit completion safety audits to assess the ship's material readiness and intensive crew training to build crew competence to undertake operations in a safe manner. Phase 4 is the deployment of the ship after being certified for combat readiness. This methodology ensures that ships attain requisite standards of combat readiness and are safe compliant in all respects. I must also highlight that warships are a complex amalgamation of a wide array of machineries, electrical equipment, and weapons and sensors integrated in a dense environment. While maintenance requirements and challenges are diverse, with advances in digitization, the Indian Navy is progressively transitioning towards data-driven maintenance by leveraging its comprehensive maintenance management system. Going forward, a common data framework and ERP solution is also under development, which aims to integrate all databases under one umbrella. The underlying objective is to optimize maintenance processes and resource allocation, thereby enhancing the overall safety quotient. Another unique methodology adopted towards enhancing safety compliance is the concept of change management, which aims to progressively replace basic electrical and engineering equipment and subsystems with contemporary systems as shown on the slide, with more advanced safety features and reliability. On similar lines, in the domain of engineering systems, the focus has been towards implementing a zero-leak policy in letter and spirit and improve firefighting and damage control capabilities. Accordingly, technologies shown on the slide, such as autonomous firefighting robots, press-fit pipes, are being inducted gradually and have resulted in safer and reliable working environments. Having alluded to the policy and organizational aspects of safety and maintenance in the Indian Navy, I would now like to move on to the aspects pertaining to hull design and stability. Ladies and gentlemen, as our platforms venture out in open seas, steel quality is the core consideration towards constructing robust platforms capable of withstanding harsh marine environments. DMR 249 Alpha steel, developed in conjunction with NMRL, offers high tensile strength, corrosion resistance properties, and extensive durability, and is now the backbone for indigenous warship construction and repairs. The Navy has also collaborated with NMRL for development of a long-lasting paint scheme which has a durability of 15 years. For the machinery spaces and hazardous areas, fire-resistant paints are being applied as a policy. Nano paints are also being steadily inducted owing to their special properties. ICCP and Cathalco systems, characteristics of warships, and with advancement in technologies, diver replacement anodes have been inducted, which obviate dry docking. We are all cognizant of the fact that underwater repairs are one of the most demanding activities, requiring the most stringent quality checks and, above all, time-intensive dry docking operations. In order to reduce downtime of ships and ensure safe repairs, Naval Dockyard Mumbai has forayed into inducting advanced robotics and autonomous hull maintenance tools, which are being effectively leveraged to enhance productivity during refits while the ship is in afloat condition. Accordingly, the slightest symptom of sweating or minor leakage is checked through these techniques such that interim repairs can be effected and exact scope of the dry dock package can be ascertained. In an ongoing refit, this technique proved to be highly effective as approximately 70% of the hull survey was undertaken prior to docking of the ship. Going further, advances in material sciences have also paved way for development of high-grade corrosion-inhibiting paint schemes, nanomaterial-based coatings, and insulation materials with better capabilities to mask noise signature and function as fire retardants. These materials have proliferated in the Navy and are considered apt to provide fire protection and ensure structural integrity, thus protecting the ships against operational hazards. Safety as a culture is being followed not only in operations but right from design stage, which we had heard from the earlier speaker. Load, stress analysis, and fatigue life prediction is enshrined in the ship design process. In addition, failure mode effect analysis has a larger ambit and extends to ascertain the fact that constructional design accommodates adequate safeties and redundancies for critical systems. In order to incorporate these elements and thus construct safer and durable platforms, advanced technologies such as 3D digital twin, which depict lifelike realization through simulated 3D constructed structures and models, are now being utilized effectively. I now move on to the very crucial aspect of weight management and stability, which underpins safe maneuverability and dry dock operations. The Indian Navy has a very meticulous mechanism of factoring and recording weight and stability changes right from design and through the life cycle of a ship. Accordingly, this aspect is considered in the most scrupulous manner. Regular audits are undertaken at various stages and advanced software tools are leveraged to achieve precision. Weight and stability management rightfully comes from the fore in case of docking and undocking evolutions. The Indian Navy follows stringent procedures and check-off lists in this regard, and the activity is undertaken in a deliberate, controlled, and cohesive manner, factoring all safety precautions. Each docking and undocking operation is preceded by detailed calculations, minutely factoring every aspect of the ship's heel, trim, and metacentric height. The docking plan is simulated through a software which serves as a benchmark for on-site dock block arrangement and alignment and actual conduct of the evolution. Further, compliance with SOPs encompassing calibrated liquid loading, complete defueling, de-energizing of all major machinery is stringently ensured. Ladies and gentlemen, safety is a top priority, but mistakes do happen, even with good systems in place, and minor safety lapses may lead to severe ramifications. The Navy does experience incidents of fire and flooding, which consequently warrant dry docking. Generally, major fires are fought on board with water jets. In the Navy's experience, excessive accumulation of water, if not discharged commensurately with while fighting the fire, can lead to heavy listing of the vessel. Thus, it is imperative that while the ship or organization focus on firefighting, there is a need to monitor the stability of the ship, volume of water accumulating in the ship, and availability of all pumping out systems on board. Docking forms one of the most critical aspects in any refit, where ship weight to the tune of 7,000 to 8,000 tons rests on 40 to 50 square meters of wood. On an average, 130 docking and undocking operations are undertaken annually at the Naval Dockyard, Mumbai. Stringent SOPs, as covered in the preceding slides, are adhered to. There have been instances in the recent past where the Navy has had to dock ships with excessive variance in weight distribution, which mandated additional precautions over and above the standard checkoff list. In one such scenario, a ship damaged in afloat condition resulted in weakening of hull in certain areas and also apparent increase in tonnage. Docking of this vessel was undertaken in a special version of dock block arrangement where the dock blocks were adequately supplemented at strong points of the hull. On a parallel term, undocking of a ship is also a very critical evolution, and the point at which the ship leaves the dock block and starts floating is the most critical period in undocking. Towards this, it is essential that all weight calculations are undertaken on accurate benchmarks. In a recent case of undocking of a vessel, large quantum of repairs led to incongruent weight changes. Thus, determining weight changes was a challenge. In order to ensure safety of the evolution, the Naval Dockyard Mumbai undertook four separate methods, as shown on the slide, to arrive at the most suitable stability conditions. Post-converging all calculations, accurate assessment of the transverse CG could be undertaken, wherein 3 of the 4 methods generated almost comparable results. Accordingly, minor weight corrections were effected to ensure zero list. Further, it was ascertained that the least value of GM was also within the prescribed limits as per the DEF stand. Factoring the criticality of docking, the Navy today is leveraging futuristic technologies towards ensuring safe docking operations. While the hydraulic retractable shape side blocks obviates dependence on tide for docking in Mumbai Harbour, automatic dock block positioning system ensures precise arrangement of blocks through laser technology. Further, hydraulic blocks ensure safe operation of dock blocks whilst providing access to inaccessible areas of ship's hull and obviating the necessity of another version of docking. Strain gauges are a technological aid which facilitate safer undocking by exactly determining stresses on the load blocks and thus arrive at a more accurate weight corrections. Before I conclude, I would like to take this opportunity to highlight the safety framework at Naval Dockyard Mumbai, which is a strategic asset of the country. Naval Dockyard Mumbai is an IMS accredited unit and is one of the first units in the Indian Navy to become compliant with ISO occupational health safety standards and is certified for quality and environmental management standards. The yard has a dedicated safety and environment division, which is headed by an officer of the rank of Commodore as the General Manager Quality Assurance. A multi-layered hierarchical setup comprising of a team of dedicated safety committee members and Central Labor Institute trained safety officers meticulously audit safety aspects in a methodical manner. The yard follows a multi-pronged strategy towards conduct of yearly internal safety audits, on-site classroom training, and mock drills on various facets of industrial safety is undertaken regularly by safety officers, external agencies, and the Indian Navy safety team. Safety stand-downs and golden safety hours are embedded in the work schedule and have proven to be effective practices. Efforts to strengthen the safety culture are sustained, and safety violation notes along with a financial penalty has proven to be a deterrent. This continued emphasis to ingrain safety as second nature through strict quality control, use of PPE, safety audits of all shop floors, and evaluation of safety processes. In order to further bolster the safety at Naval Dockyard Mumbai, infrastructure has also been suitably augmented. A state-of-the-art dockyard operations center functions as the nodal point for coordinating emergency response in case of a fire or flooding incident on board a ship or even in the yard. This facility is equipped with adequate resources comprising of additional emergency response vehicles, fire tenders, and is manned by specific domain specialists. Dockyard Operations Center also has a repository of each and every ship's layout and diagrams, firefighting arrangements, stability data, which facilitates informed decisions by the emergency task force. The center further has a Navy-specific equipment called Remote Support System, which renders maintenance assistance to ships at sea through a satellite link over the Navy's Rukmini satellite. In the end, I would say that we in the Indian Navy are not only inducting state-of-the-art contemporary technologies towards making our ships and submarines safer, but are also consistently revamping our processes and standard operating procedures to be in consonance with evolving global standards. Thank you. Jai Hind, Shanavarun.
Thank you very much, Commodore Shidore. You have finished your talk precisely on the dot of 20th minute for such a wide-ranging topics. Without wasting much more time, our last speaker, Commodore Deshmukh, on the subject of defense analysis. Commodore Deshmukh.
Meticulous maintenance for the enhancing the safety of
Thank you. Yeah, defense analyst. That's what it says here.
senior officers,
I don't know. I went by this.
Colleagues.
What is written here?
ladies and gentlemen.
My apology if I have made a mistake.
No problem, sir. After seeing the operations and the design requirements, it's a turn that we focus onto the maintenance part of it. And the presentation would deal with meticulous maintenance as required for the enhancing the maritime safety. Before I start, my gratitude to Admiral Pasricha, who as early as 1996 gave me a chance to associate it with a very high-tech project for setting a maintenance facility for Sea Harrier aircraft in India. And that has been an eye-opener and a learning experience. My gratitude, sir. So before we talk about the maintenance, it is important to understand what are the importance of the maritime fleets in India. As a maritime fleet, we can say that whosoever command the ships, command the trade, and ultimately it leads to the conquering the world itself. That's the importance of the merchant fleet wherever we go into the world. It is very important for us to understand why the meticulous maintenance is applicable to the merchant fleet. if we see that merchant fleets are important for us because 80% of the trade of the whole world transits to the sea lines of communications. Post COVID incident, if you see the graph, we see that the maritime fleets are now started operating at the optimum capacity and the trade is increasing. Today, almost 50,000 merchant ships are operating out at sea. And with such a great number of ships there, we have to be meticulous about the safety and the maintenance part of it. Nearly 2 million seafarers are working on them. Therefore, as pointed out by the Captain Naik, their safety also is equally important, and it is based on the meticulous maintenance of the assets they operate. Once we deal with the merchant ships, protecting the sea lines of communication, our EEZ and the other assets, the armor navy comes into the play. That's a requirement. Now to the 50,000 ships for the merchant fleet, if we add the naval ships also, we can see the complex scenario wherein safety aspects are required to be taken care of. For the safe operations of so many ships operating around, it's very important for us to protect the human life, ships, cargo, and the environmental hazards into the sea. There are many regulations, including IMO and SOLAS, which deal with safety aspects, including the maintenance part of it. Despite this, the safety of the merchant fleet requires a combination of strong global maritime infrastructure and the skilled manpower. And as has been pointed out, the skilled manpower is one of the problems nowadays fleet ships are facing. The criteria for the naval ships as such is entirely different, wherein we talk of the weapon safety, advanced technological capabilities, and personnel with specialized training. Here also, including Indian Navy, we face the manpower shortages. Thus, for the maritime safety, measures are required to be designed to protect all assets, including the life. The core requirements which warrant are seagoing vessels have to be as per the specific safety standards, and they need to meet the varied operating conditions. They need to be equipped with approved maintenance appliances, navigation aids, and the safety systems. They also require to go regular inspections, maintenance, to ensure the continued safety of the vessel and the crew on board. The operational maritime safety involves effectual and regular maintenance. For cargo operations, cargo needs to be, particularly the dangerous cargo, needs to be secured properly, and handling equipment has to be properly maintained. All seafarers need to receive proper training and certification, and the problems of certification have been pointed out earlier. The certification can be bought. The crew also need to be trained for managing the risks on board, following established procedure, and clearly understand collective responsibility. Individuals may do a job, but the weak link could be a danger. They also need to undergo periodic training for mastering the best of the practices. Despite all this, we see that the breaches do occur and the disaster accidents have happened. First of the case study deals with Dali. It has been already spoken about. So what I will speak here is the exact cause which has been pointed out by the original equipment manufacturer. There is a relay box which connects to the generator. When the relay box number 1 failed, the crew, when in the port, switched on to the relay box number 2. When the ship started sailing from the Baltimore harbor, the number 2 relay was in operation. However, crew failed to do the independent inspection, and there was a loose connection wire in the number 2 relay box, which ultimately led to this disaster, which points out the clear-cut requirement for the meticulous maintenance as well as the independent inspection of the critical work which has been undertaken. This is what Dali incident tells us. The second study deals with an incident which was reported on July 24 when the ship ran aground in Greece. The MN Costas, it sank rearwards into the river and it blocked the river and the navigation hazards were created. When they did the investigation, it was pointed out that the equipment like depth measuring equipment and the other sonar equipment was unserviceable. These unserviceabilities were known to the crew into the port. Despite that, they chose to sail and ultimately landed with navigational error, but the real cause was the maintenance problem. Then we come to the what we call cost cutting for the maintenance. Today, earning profits is the motto. Hell or heaven, safety is neglected. Therefore, as been pointed out earlier, the owners need to be held responsible for the neglect of the maintenance. One of the effect was when the maintenance was neglected was the TS Type I, which broke into two in 2016 and sank up to the door of the ship. The crew was somehow evacuated from there. The cause was clearly pointed out was the poor maintenance standards, and here is the lesson that meticulous maintenance is absolutely essential for the safety. Effect of the time cutting. This was also spoken about. Many people highlighted that the pressures on the maintenance crew. This case relates to US Marine. When the new equipment was supplied by the original equipment manufacturer for the exercise, because of the pressures of the exercise, the acceptance tests were not properly, and the boat was deployed with a crew of 6, which ultimately, because of the unsafe standards of the boat which has been supplied, actually sank and the 6 crew died. Once again, this reiterates the requirement for the acceptance standards to be meticulous as well as the maintenance standards to be followed. Finally, when we talk about the maintenance, we obviously have to keep up with the times. We cannot go with the screwdriver technologies when we are talking about the laser technology or the standard technologies coming in. Therefore, as was pointed out, dockyards have already started implementing the advanced technologies. Therefore, we also need to go toward the maintenance wherein digital twins are created, which give us the state-of-the-art information about the equipment status and their maintenance status, and we can adopt to those technologies. IoT is another tool which gives us the correct information about the maintenance status and the operational status of the equipment on board. Then AI and machine learning are another tool which can be utilized, which allows to save us the manpower and on the documentation part of it. Blockchain, it is just coming in today, and specific trainings will have to be imparted for the people to learn about the blockchains and utilizing them for the ship's maintenance and maintaining the safety standards. Automation and robotics also has been spoken about, which is leading to the safe operations on board, wherein the areas which are not safe for the human being to operate from can be accessed by the robotics, and other things are to be done. Especially the hull inspections, once they are done by the robotics, it cuts down on time and the accuracy improves. However, it is extremely important, and it was pointed out earlier, just because technology has improved, advanced tools are available to us, we cannot afford to neglect man behind the machine. Ultimately, the man behind machine cannot be replaced for the meticulous maintenance part of it. Therefore, it is important that there is an integration of the advanced technologies along with the training of the crews who maintain the ships, and the owners also understand requirements for the high technology, spend money for that, and go forward from there to enhance the maritime safety. In conclusion, I would like to say that maritime safety should be imbibed by all. As it was pointed out earlier, it is not only one person's job. Collectively, all of us have to rise to ensure that maintenance is done correctly and adequate time and funds are allocated for the maintenance so that we move away from the disasters. The ship's crews also need to be properly trained and exercised again and again so that the safety culture is imbibed by the crew. Finally, I would like to end. Safety is a small investment for the enriching future. It speaks for itself. Thank you very much. Jai Hind. God bless.
Thank you, Commodore Deshmukh. You have also observed time discipline very well. That brings us to the next item of inviting questions from the audience for our honored speakers. So I'll throw the floor open. Kindly identify your name and limit your comments to a question, preferably.
Thank you, sir. I'm Vice Admiral Subedar, former COM. My question is for the Warship Design Bureau. You have covered mostly all aspects of the ship design and the historical perspective, right up to the future plans. But can you just enumerate or tell how the maritime safety features are embedded at the design stage? You have not covered that portion.
Sir, I showed the design spiral. So whatever we do in the design spiral, there are limiting values and guidelines given in the NES specification, our own specification, and there is a check done by the FOS team also. They approve the general arrangement of the ship, and they also visit the ship as part of the UIG, user inspection group, at shipbuilding stage. Sir. At different stages, they go and check. Sir. Thereafter, once the ship is constructed, delivered, thereafter another level of check is there, where again DFRs are generated, guarantee defects are generated, which are implemented by the design bureau on the ship, sir.
The question, I think, was asked. Right, I'll take yours.
I'm Vice Admiral Verma, retired. What Subedar was trying to say was, how do you build safety into the design? What you're saying is fine, you do all these things when you go in for construction, it's too late. There has to be safety built into design, So how are we doing that? Because you are already designing so many issues. How are you doing that in terms of thing? Not the other things will be done in any case, but how do you know your design is safe? That's the question.
Sir, again, I'll come to the design spiral. So there is a first loop when we do, like say stability. There are NES guidelines which give what should be the minimum GM, what should be the area under the curve. Those kind of values are given for stability. Similarly, when we come to sea keeping, there are sea keeping norms which will reduce the fatigue on the crew. So we design as per those norms. In certain sea states, the crew should not be fatigued, and we should be able to fire our weapons. That is those checks are also there. Then when it comes to maneuvering, so with maximum rudder, what is the angle at which the ship will heel? So those values are also defined. Thereafter, when it comes to the GA, the general arrangement of the ship, how do I minimize movement of crew from one location to their place of work? All those things are there. The angle of the ladder, how the hatches are to be positioned, how the doors are to be designed, so that they create minimum injuries in operation. So we are having a lot of cases where those things are happening. But we are continuously improving. When we do the aerodynamic studies for the helo deck, we are analyzing how the wind profile is coming for helo operation, how the plume from the exhaust is coming there. So that is also there. When I say survivability, again safety is part of survivability. At different angles, when the weapon is going to hit my ship, how am I countering it? How am I minimizing my signatures? That is also part of the safety. And
I am Commodore Kumar.
May I just a second? Can I add to his, if you permit me? So far as I understand the situation on the merchant ship side, as all of you know, that merchant ships come in various sizes and various lengths and beams and depths. And those, as far as those things are concerned, the broad safety issues like the life-saving appliances, the firefighting appliances, the subdivision, cross-flooding, number of watertight bulkheads, etc. They are pretty well designed, they are pretty well laid down in IMO's Safety of Life at Sea Convention. And as the design progresses, as the construction progresses, after these basic things are laid down, then the classification society surveyors, they see the departure.
And building capability of the Indian Navy.
Yeah, he had only 20 minutes. He has he
No,
dealt
that's-
with tugs,
And
he dealt
secondly-
with survey vessels. Let me complete. He dealt with tugs, he dealt with survey vessels, he dealt with corvettes, he dealt with frigates, he dealt with destroyers, and he also spoke about aircraft carriers.
But he left out submarines,
And he
including nuclear
his,
submarines.
he wound up his speech by a pat on the design part of Prime Minister Modi. One of the slides presented by Rear Admiral Bakshi, it contained a pat on their back of Prime Minister Modi with regard to the new Vikrant. You see? So I think he has done a good job, and he had short time.
And secondly, about the, you must be having a factor of unsinkability of each ship. That,
Yeah. Thank you. Thank you. You wanted to ask, sir?
Just want a suggestion that in the aviation of the Air Force,
Oh, yes.
we have a factor of safety.
Oh, yes. Oh, yes. Oh, yes.
We have a term called factor of safety.
That's right, yeah.
And if that is defined properly,
Yeah.
or it is audited properly, then the aircraft or the structure is always safe.
All parts into a ship design and ship construction, they integrate a factor of safety. You see? Yes, of course. Everything gets audited every step of the way. But here I must say, a great departure I find in the Indian Navy vis-a-vis the ships that are constructed in merchant navy. You see, the ship owner who constructs a ship, merchant ship, in a private shipyard, he is assisted by intelligence database of classification societies. But here I find everything is in the house. See, that is where the scope and nature of responsibility that is shouldered by somewhat narrow shoulders of Rear Admiral Bakshi are quite heavy, to take care of all this, the design aspect and then the construction aspect also. So I must salute you, sir, which is a departure from merchant ship practices. That's it. Yes, sir. Take a mic.
He said that they wanted to make 100 warships in 25 years. Don't you think that the infrastructure should be also upgraded, because in all these years it took 100 ships to make 50 years, and you're going to make 100 ships in 25 years. Don't you think that with the present infrastructure of the Navy, are you going to achieve that? Yeah, ships and submarines, yeah.
Yes, sir. Sir, one is to take on the challenge and do it. So we have taken on the challenge. Secondly, if you generally see the shipyards, a lot of shipyards are there here. They have capability. Now they are going for a lot of MOUs, they are going for tie-ups with private shipyards. So that augmentation is happening. Because one is the demand which is coming from the warships. Also they are expecting demand from the commercial side. So we have MDL reps here. They are making new shipyard in Tamil Nadu. CSL is also making one new shipyard in Tamil Nadu, sir. Already something is coming up in Gujarat. There's something, Andhra government is tying up with Hyundai, and they are making something there. So things are happening. So next 5 years we'll see a lot of change. In fact, MDL is making a new dry dock. It's a roll-on, roll-off kind of arrangement in Navasheva. So everybody is expanding. GRSC, when you go and ask them, they have capabilities. L&T, sir, is there. The L&T has got capability. Means capacity is there. So capacity is there. More the demand comes, I think that pull will happen. So more resources will go in, more engineering will happen in the country, more skilled people will get trained and move into that direction, sir.
If I may add to his comment, I may suggest perhaps you may take a visit to Karwar base, the Indian Navy base that has now undertaken a massive infrastructural expansion work, and it's worth visiting that place now. It's a complete departure from the Karwar that I had seen maybe 20-25 years ago. Yes, sir.
Let me begin by congratulating your Bureau for the wonderful work that you've done. And I can humbly and modestly say that I've been part of your success story. But what I'd like to ask you is, how much effort one of the problems that I faced on the other side, being a shipbuilder, was dealing with the specifications that Indian Navy used to put out to, it's very demanding. And then sometimes, they are at odds with one another. So what efforts have you made to rationalize specifications across the board for building ships? If you do that, I can tell you that the time that you're taking to build ships will come down significantly. So what actions is the Indian Navy taking to rationalize specifications?
You want?
Sir, it's a continuous exercise. So we have already finished one exercise now. So we have revised our SOTRs. Now, what used to happen earlier was SOTRs used to be frozen after placement of order. Now we are giving SOTRs along with the RFP. So those SOTRs are frozen. What will come after the contract is only ship-specific detailing, which will come as from the shipyard and will be approved by the design bureau. It will no longer go to various directorates and those kind of things. So we'll save on time with respect to that. So at least the equipment part is frozen, sir. So that will save time. Secondly, we are looking through Nirdesh of a national shipbuilding data network, which will be a permanently available network connecting all shipyards, QA, everybody. So all the data, 3D modeling, the SOTRs, the drawings, the planning management tool will be available on day one on that network. So we are pushing through MOD DP. So that will further cut down timeline. There is a study which was done by QA which said that 250 days the drawings are taking to move, and in 10 days they are getting approved. So we are trying to cut down that 250 days so that it's a real time approval of drawings and it moves faster. So we are trying to cut down timelines. And even planning management tool which used to come say up to 3 years down the line. Now we are looking at planning management tool being available on the very first day, so that we cut down that timeline of decision making.
We have already done. Let me tell you, my experience working on Soviet origin ships, the SNF, the SNR, there is a standardization of equipment. You have a pump. The same pump will be fitted on 4 different classes of ships. Are we doing anything to do something like that? To standardize the pumps, standardize various equipment, so that you just have to increase the capacity. But the design is, frozen. The numbers will change, but everything is standardized. That's what I was looking at.
I may just add some observations with my background only from the merchant navy. You see, now we are in the 75th year of independence, and we on the merchant navy side have completely missed the bus of constructing our own ships for our own exim trade, and as against that, now, as you know, recently our Prime Minister has undertaken a massive program of concentrating his attention for the merchant shipping development. So earlier speakers also have identified how much we totally depend upon international merchant shipping for our exim cargo, and what a huge freight bill that we are paying out to take care of our exim cargo. As against that, the warship design and warship production, they are doing, in my opinion, in comparison to merchant ship construction world, they are doing a fantastic job of shouldering the responsibility of classification as well as design details and as well as getting into the job of production itself at the shipyard. Let me share with you one or two small stories of my personal experience. I took to merchant shipping career in the year 1958, and there was an occasion for me in my life when I had to visit naval dockyard near Lions Gate as a 17-year-old lad then, and the speaker of the day, perhaps Admiral Pasricha will remember him, Admiral Pereira. Do you remember him, sir? And Admiral Pereira was the speaker. He was then at the higher echelons of Navy management, and the entire naval dockyard was full. And I am, as a 17-year-old young merchant navy lad, listening to this Admiral Sequeira, and he took the entire audience, he kept the entire audience spellbound with whatever that was, taking place there in the naval dockyard those days. And today I heard Rear Admiral Bakshi and about the wide-ranging activities that are under his control. I mean, they are simply amazing. So, at least I personally stand greatly assured by the role of Indian Navy vis-a-vis the merchant navy. I may just add, the time has come for me to do my own, so to say, summation. So I shared with you one story about Admiral Sequeira. I heard him long back in the year 1960. Pereira, sorry, not Sequeira, Pereira. I was very happy to know right in the beginning that INS Vikrant I, which Admiral Pasricha was very closely involved. I made a mistake. I made a mistake in that name, Catholic name. INS Vikrant I, with which, sir, you had something to do very much. And one of the sad events that has happened in my life was to see the state of INS Vikrant lying in the naval dockyard, unattended and in debilitated and badly in bad state. You see, there was some problem with regard to disposing of the INS Vikrant or converting it into a museum, and it was a very sad story for we merchant navy men to go in and out of that Alexandra docks and see INS Vikrant lying there like that, corroding away and broken up. Anyway, that's another point. Another thing I may perhaps observe, I tried to explain what a fantastic job warship design and warship construction is being done by Indian Navy. I explained to you the sad story on the merchant ship design. With regard to refit, also, I find Commodore Shirode, he dealt with the subject of the problems that are in his field. Some of the things that I liked, which perhaps the new growing shipyards, small shipyards cropping up in India now, we already experimented with some of them, but they had to close down for various reasons. All of you perhaps know their stories very well. I don't want to go into detail, but I liked one particular practice that they undertake, namely operational risk management. You see, this is a concept which I think is absent in Indian shipyards or Indian even ordinary marine workshops. Operational risk management which is identified for labor to follow, That is what one point I would like to share. Another point that simply amazed me, of which I was totally unaware, was robotic scanners for identifying structural defects in plates as thick as, 30 mm. You see, so robotics being employed for this purpose also is certainly an area in which in a merchant ship world has still to has still to make some progress. Case studies were very nicely identified. I am very somewhat relieved to know that you have fires on board the ships, and you have water accumulations, and you have stability problems. So that is one thing we share with merchant ships, you see, Indian Navy. Commodore Deshmukh, I got lost whether he's speaking of, I took him to be a man from the merchant navy. His entire presentation applied everything to a merchant ship's functioning. Am I right, sir? So I actually seriously asked him what is his background. He says he is a mechanical engineer and then went into Navy and aviation. That's right, yeah. So having said that, Admiral Nadkarni, I think I have managed to maintain some measure of discipline with regard to time front. And thank you very much for giving me this opportunity. Yeah.
Sir, just one point. Since the forum is there and all thinkers are there, I would like to put across one point. In naval shipbuilding, on the day I place the contract, I don't know what equipment is going to come. I take 2 to 3 years just to decide and finalize, and then the supply chain. The item keeps coming, and that has to go inside the ship. So when we say productivity of our shipyards or our production timelines vis-a-vis any foreign country, it's not bad. They start the contract, they know which equipment is going to come, their designers have already designed, there's no change in design. In our case, we don't know. So when a foreigner says he makes a ship in 4 years, actually our shipyards can make in 4 years, I'm giving 5 years suppose, but they can make in 4 years. All future ships, now we are looking at 4 years production time and 2 years preparation time. That 2 years I cannot do away with. So it's a thing of pride. Like you made the carrier, sir. For a carrier to come out of our country in Cochin shipyard, it's a commendable thing, sir. When you stand in front of the ship, like I said, 1983 moment is that 2022, sir. When India won the Cricket World Cup, and here we made the carrier. And that carrier has brought about the change. And today what is happening is thanks to CSL and aircraft carriers.
Yeah, and that's what got them the pat on their back from Prime Minister just a short while ago. And he has identified that in the slide. I'll just make one small point. You see, Indian Navy is very actively supporting small prefab units. You see, I would say they depend to a great extent on small workshops who indulge in prefab units, you see. So there is a big encouragement that is coming towards the growth of, I would say, mechanical engineering units by way of Indian warship design and warship construction for such manufacturers. This is one very important point I thought I'll make. Yeah, there is somebody else who's asking a question. Yes.
Sir, good afternoon, sir.
Yeah.
So I'm Wing Commander Narang. My question pertains to Commander Deshmukh and Rear Admiral Sujit. Sir, do you think we are at a stage to shift our maintenance philosophy from time-based maintenance philosophy to probably requirement-based maintenance philosophy, and probably even future to prediction-based philosophy? Because we do have the sensors, we do have the AIML, but we need to put them at the design stage. Hence, it concerns to both of you, sir, if you can throw some light on it, sir.
First of all, thank you so much for this particular question. Let me assure you that the aviation as such in India itself has taken a leaps and bounds as we go toward the what we talk AMCA and other things. What we had been lacking earlier, that we never interface the private sector into the building of the aircraft. Now that lacuna has been removed, wherein when we are talking about the advanced combat multi-role aircraft, today L&T, Bharat Forge, Mahindras are standing on the cusp, and not I'm casting aspersion, but HL is actually started sweating. Now when these people come in from the private sector, they are well aware of the technologies, they know exactly what is available in the world today, and they would like to earn a name that they have made the safest of the aircraft with the best of the maintenance technologies to reduce the downtime and have an operational time. So we are already heading toward that, and probably another next 7 to 8 years you will see whatever you have said will come in the reality. And I'm genuinely happy that you asked the question. I did my training with Air Force Technical College, so the fraternity is always there. So whatever we do in industry, we will ensure it comes to the Air Force. Thank you so much.
This maintenance philosophy which you spoke about, like when we go into our hull maintenance philosophy, like earlier the kind of paints and steel which we had to do docking every 1.5 years, 2.5 years. Today we have technology indigenous, the paints and the steel. We have straight away gone for 5-year interdocking interval. I don't have to dock my ship in those 5 years. And he's using technology where he's trying to reduce timeline. So
to answer your question, we're already into CBPM, that is condition-based predictive maintenance. If you look at gas turbines, which we talk about, which are propulsion plants or even power generation, when the Russians gave us this turbines, we were doing 5,000, 6,000. Now, using vibration analysis, we have already extended the life of the maintenance routines. We have already extended the life to 7,500 now. And that is purely based on condition-based predictive maintenance. So the Navy has already gone into this phase of, though we are following a part PPM, part CBPM, but we are definitely transitioned in a big way into CBPM.
Yeah, just last point before I hand over the mic to my friend Admiral Nadkarni. I used to visit Mazgon docks long back when Mazgon docks had just remained under British management pattern until the Mazgon docks was taken over by the new ministry in the government of India called Ministry of Defence Production. All my colleagues here, they come from the Ministry of Defence. Am I right, sir? And there is a separate ministry set up called Ministry of Defence Production, where units like Mazgon docks are handled. Garden Reach, probably in Calcutta, is handled by them. And what an expansion that the Mazgon docks has undergone over the years. I used to dry dock small merchant ships regularly in the Mazgon docks. And then Datta Samat came along and made sure that he put a big lock outside, you see. And then that is when the Ministry of Defence Production was born. And then we started constructing submarines there, am I right? You see, so a lot of growth has taken place at the waterfront, you know, and I feel very proud that I belong to both these. I like to say that I belong to Indian Navy also, just as much as I belong to Merchant Navy. And I'm really happy and grateful that I am called to, so to say, moderate this session with these excellent speakers here. I stood to be greatly benefited, sir. I assume both of you are from Naval Arc background, no? Oh, you are also marine engineer. Oh, from which institute? Oh, you have your own in-house, INS Tir and all that. Yeah, very good. Thank you very much, gentlemen. Thank you very much, sir.
I would like to thank Captain Nafde and the three speakers, Admiral Bakshi, Commodore Shidori and Commodore Deshmukh. And especially, I think we can now grant honorary naval rank to Captain Nafde. Though he was in the minority, I think in his own inimitable way, I think he kept the audience totally engaged. And I'm happy that there was such an interactive session also with the audience asking so many questions and we getting some very good answers from the panelists. With that, we come to the end of this session. So may I request President IMF to kindly give the mementos to the moderator as well as the three speakers. Firstly to Captain Nafde.
I wonder whether the gift is from a friend to another friend or from the president of IMF to an ex-nautical advisor.
Next to Admiral Bakshi. Then we have Commodore Shidore. And finally we have Commodore Deshmukh.